Why time slows down near a black hole. Relativity Simplified. Have you ever wondered why time behaves differently near a black hole? It sounds like science fiction, but it's a real and fascinating effect predicted by Albert Einstein's theory of relativity. Let's explore this mysterious concept in simple terms. What is a black hole? A black hole is a region in space with an incredibly strong gravitational pull. It forms when a massive star collapses under its own gravity. The pull of gravity in a black hole is so strong that nothing, not even light, can escape from it. The boundary around a black hole is called the event horizon. Once something crosses this point, it's lost forever to the black hole. Einstein's big idea, general relativity. To understand why time slows down near a black hole, we need to know a little about Einstein's general theory of relativity. Einstein said that gravity is not just a force, but a bending or curving of space and time, together called space-time. Massive objects like stars and planets bend space-time around them. The more massive the object, the more space-time bends. Time and gravity are connected. Here's the key idea. Gravity affects time. According to relativity, the stronger the gravitational field, the slower time moves. This means that time actually ticks more slowly in places where gravity is very strong. This effect is known as gravitational time dilation. Imagine a clock near a black hole. Let's say you place a clock far away from a black hole and another clock close to its event horizon. To someone far from the black hole, the clock near the black hole would appear to tick very slowly. Seconds would stretch into minutes. Time, in a way, is being stretched by the gravity. What would you see? If you were watching a friend fall toward a black hole, safely from a distance, you would see them slow down as they approach the event horizon. In fact, from your point of view, they would never actually cross the event horizon. They would just appear to freeze in time. But your friend wouldn't notice anything strange. From their point of view, time feels normal. That's relativity. Different people can experience time differently depending on where they are in space and how fast they are moving. Real-world proof. This might sound like science fiction, but scientists have actually measured time dilation here on Earth. For example, GPS satellites in space experience weaker gravity than we do on the ground, so their clocks run slightly faster. Engineers have to adjust the satellite clocks to match our time, or GPS wouldn't work correctly. Now imagine this effect multiplied by billions near a black hole. That's how powerful gravitational time dilation can become. Spaghettification and the ultimate stretch. If you got too close to a black hole, not only would time slow down, but you'd experience something called spaghettification. Gravity near the black hole is so intense that it stretches your body like spaghetti. While time slows down, your body gets pulled apart because gravity is much stronger at your feet than at your head, assuming you fall feet first. Does time stop at a black hole? From the outside observer's view, yes, time appears to stop at the event horizon. But for someone falling in, time flows normally until they reach the center, or the singularity. At the singularity, our understanding of physics breaks down. Time and space as we know them might not exist there. Conclusion. The mystery lives on black holes are not just cosmic vacuum cleaners. They are windows into the deepest mysteries of the universe. The way they stretch and slow down time challenges our everyday understanding of reality. Thanks to Einstein's relativity, we now know that time is not absolute. It can change depending on gravity and motion. Understanding how time slows down near a black hole helps us appreciate how strange and wonderful the universe really is. It also reminds us that time is more flexible than we think, a concept that could have even deeper implications for science, space travel, and the future. Like and subscribe.